Hello, my dear students. Today we came here to discuss some important examples on dipole moment. So it is the extension of our previous class. So basically, it is the part 2 of dipole moment, and I am providing the link of the part 1 of that class. Okay, so if you have any queries, you can follow our part 1 channel or dipole moment, and you will get the link on the comment description box. So without wasting time, let's start. So our first question is, what will be the dipole moment of CH4? What will be the dipole moment of CH4? So if dipole moment exists, that means the compound is polar. So if is it polar, is CH4 is a uh, CH4 is a polar molecule, is a polar or not? So what will be the answer? CH4 is a polar molecule or not? Okay, I have discussed already the dipole moment of CH4 in our previous class, but I am repeating this topic here again. So at first, uh, before uh, going through the polarity of CH4, uh, my dear students, you should know the bond moment of CH. What will be the bond moment? What will be the bond moment? Bond moment of CH. Basically, the CH bond moment uh, is like this. That is, the direction of the bond moment of CH is from H towards carbon. That is, for in our previous class we have already discussed the bond moment basically depends on the two factors. Number one, the more electronegative atom, the more electronegative, the more electronegative atoms. Here, in case that is carbon, pulls the bonding pair of electron, the bonding electron pair towards itself. Number two, intrinsic homopolar dipole, which so what is the homopolar dipole? In our previous class we have already discussed, in the homopolar dipole, the more compact orbital pulls the electron pair towards its own nucleus. So here hydrogen is more compact and small in size than the carbon atom, so the bonding pair will be pulled towards the hydrogen nucleus more. So intrinsic homopolar dipole, in which hydrogen pulls the bonding pair, but in case of CH, this effect predominates. So effect one effect one is greater than effect two. Therefore, the net bond moment, that is mu CH bond moment, is from hydrogen to carbon, that is from hydrogen to carbon, and mu CH is almost 0.4 dBi. The value of mu CH is almost 0.4 dBi. And my dear students, please write down the notes. Please write down the notes on your copies. Otherwise, you cannot get this. Okay. So write down the notes. I think the board is quite visible, so you shouldn't have any problem to write down the notes. So now we'll go to discuss the structure of CH4 and its polarity. So actually, so what is the dipole moment of the CH bond? The CH bond dipole moment is basically 0.4 dBi, and the direction of the bond pair moment is from hydrogen to carbon. This is the main thing. So let's start. So what we have informed? We have informed that mu ch is from zero point 0.4 dBi, and it is from hydrogen to carbon. The direction of mu is from hydrogen to carbon, and this is our picture. And this is, if this is the z-axis, and all the bond angle, so such bond angle is 109 degree 28 minute, and the angle is 180 degree, so this angle is 180 degree minus 109 degree 28 minutes, so it gives basically the value 70 degree 32 minutes, 70 degree 32 minutes. So all the hydrogen atoms, so all three hydrogen atoms, this one, two, three, these three hydrogen atom, these three hydrogen atom, basically these three hydrogen atom, all the three hydrogen atom makes 70 degree 32 minutes angle with the z-axis. So all three, one, two, three hydrogen atoms make 70 degree 32 minutes angle with the z-axis, with the z-axis, which correspond. So basically the z-axis is the axis of the rest hydrogen atom, so which correspond to the axis of fourth hydrogen atom. So you can also standardize the first hydrogen atom, then this will be the our axis. So I am here standardize the fourth hydrogen atom, and we get the hydrogen atom axis is the z-axis. So what will be the mu ch3? What is the mu ch3? Mu ch3 is basically, mu ch3 is basically nothing but the dipole moment, the bond pair moment, the bond pair moment of the three hydrogen bond, three hydrogen carbon hydrogen bond, one, two, three. So this one, and this one. So bond pair, total bond pair moment for the three hydrogen atoms to, bonded to the carbon atom is mu ch3 is nothing but 3 into mu ch. So what will be the value of ch? 3 into mu ch cos 70 degree 32 minutes. Why I take the cos theta? Because the resultant value, so all these are like this. So their resultant value along the z-axis is nothing but cos theta. The resultant, the dipole moment is a vector quantity. So the resultant dipole moment towards the z-axis is mu cos theta. So the value of the cos theta, cos 70 degree 32 minutes is 1 by 3. So value of mu ch3 is nothing but mu ch into 1 by 3. So it gives mu ch. So it is basically 0.4 dBi. So here, due to the three hydrogen atom, the mu, this is mu ch3 equals to actually basically mu ch 0.4 dBi, and for this hydrogen carbon bond, for this hydrogen carbon, look, for this hydrogen carbon bond, the basically for here the mu ch acts as in the opposite to this bond, this dipole moment. So this is also 0.4 dBi. So basically this dipole moment and this dipole moment mutually cancel each other, therefore ch4, so the fourth carbon hydrogen bond moment cancel the resultant mu ch3 bond moment. Therefore net dipole moment of ch4 equals to 0. So net dipole moment of ch4 is basically 0. So mu CH4 is nothing but 0. So CH4 methane is not a polar molecule. So methane I'm writing here. So CH4 is non-polar. CH4 is non-polar. I hope my dear students you can get answer my answer. So CH4 is a non-polar molecule. Okay, so please write down the notes. We are moving towards the next example. In our previous class we have at the last session we have given a problem. So the comparison between the dipole moment of NH3 and NF3, the comparison between the dipole moment NH3 and NF3. So mu NH3 and mu NF3, which one is greater? The structure of NH3, we all know the structure of NH3 is tetrahedral. So here hydrogen, 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 and this is the lone pair. This is the lone pair housed in a sp3 orbital. Okay, so here the lone pair moment acts in the opposite direction, and here the mu the bond moment between the hydrogen and nitrogen acts towards the nitrogen because nitrogen is electrically more electrically negative. So the net dipole moment, this is the net dipole moment, the net dipole moment of NH3. Okay, and here the NF3, here I can write the chi. This is the chi, that is the electronegativity. Electronegativity of nitrogen is more than the electronegativity of hydrogen, but here the electronegativity of nitrogen is less than the electronegativity of fluorine. That means fluorine is more electronegative. So bond pair moment actually acts towards the fluorine atom, and here the lone pair moment, this lone pair moment acts in the opposite direction. So basically these two dipole moments cancel each other, but not to the zero, but to some extent, to some extent, to some extent, the lone pair moment and the bond pair moment cancel each other. Okay, so number one I am writing here, in case of NH3, the bond pair moment of hydrogen nitrogen bond and the hybrid lone pair moment of lone pair of electron on nitrogen atom acts in same direction, which which gives NH3 a higher net dipole moment. That means the three bond pair moment and the lone pair moment acts in the opposite direction, act in the same direction, not opposite, acts in the same direction. Therefore the net dipole moment of NH3 increases. Okay, but in case of NF3 the scenario is quite different. In case of NF3, the bond pair moment and the lone pair moment acts in the opposite direction. Although these two dipole moments cannot cancel each other, but mutually these two dipole moments act as the mutually the two dipole moments act opposite in the acts opposite in direction. So they cancel to some extent, not 100% cancel each other, but they cancel to some extent each other. Therefore the net dipole moment of NF3 is quite less. Okay, so I am going to write down the things here. What will be the number 2? Please write down the things, my dear student. Please write down the things. Okay. So number 2, in Na3, the bond pair moment of nitrogen fluorine bond and the hybrid lone pair moment acts in opposite direction. So the net dipole moment of NF3 is very small. So therefore the result is mu NH3 is greater than mu NF3, and the basically these type of questions are very often asked in your competitive exam. So my dear students, today we will stop here, and in our next class we will see some more critical examples and on some more critical topics of chemistry. Okay, my dear students, if you do have any queries and any doubts, please write down in the comment section, and please subscribe my channel. Okay, till then, goodbye.